Examining distributions. A distribution of a variable will tell us what values the variable takes and how often the variable takes those values. We will do this for both categorical and quantitative variable, but first, categorical variable. Consider the observational study where we wait at the stop sign to observe if a car stops at the stop sign for at least 3 seconds or not. If a car stops for 3 seconds or more, we check yes. If a car stops for less than 3 seconds or does not stop at all, we check no. We observed 15 cars and the results are first car, no. Second car, no. No, 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 yes, no, yes, yes, no, no, yes, no, no, no. There are 15 responses. There are 15 results here for 15 individuals. We can group these responses into two groups, yes or no. Therefore, this is a categorical variable. In examining distribution of this variable, we first need to know what value the variable takes, in this case simply yes and no, and how often the variable takes those values. This means we need to count how many yes and how many no, the count for each value the variable takes. And so we will summarize this. For this categorical variable, the two groups are yes or no. We see that for no, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There are 11 counts for no. And 1, 2, 3, 4 for yes. The total count should be 15 because we observe 15 drivers, 15 cars. We then compute the percentage of each of the values. The corresponding percentage will be the count of each value. In this case, for yes, there are 4 counts over the total 15, and then we multiply 100%. 4 divided by 15 times 100% is 26.7, which we're going to round to 27%. For no, there are 11 counts divided by the total 15 times 100%. And we see that this is 73.3%, and we will round it to 73%. The total percentage should add up equal to 100%. This is what we call the numerical summary for the categorical variable. And this is the distribution of the variable in our study. In addition to the numerical summary, we will need to construct the graphical displays for the distribution. The graphical displays for the categorical variable will be either pie chart or bar graph in this class. A pie chart is simply a circle. The circle consists of 100%. So in this case, the circle consists of two components, two values only, yes or no. The value yes takes up 27%, and that is a little bit more than a quarter of a circle, and that is 27%. The value no takes up 73%. The percentages in a pie chart should add up equal to 100%. Usually, we color or picture code the pie to make it look nicer. For a bar graph, we list either the count or the percentages of the values. So in this case, there are two values. And so we first put the number line, and on the horizontal axis, we would put the values of the categorical variable. In this case, it is either yes or no. It doesn't matter whether we put no first or yes first. And then we put either the count or the percentage. Regardless whether we decide to use the count or the percentage, the height of each value should be the same. So for example, let's just say that we use the count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And so for yes, there are 4. So we would draw a bar that is 4 counts height. And for no, there are 11 counts, so we would put up a bar that is 11 height. The width of these bars should be the same. We don't want to make one bar wider or narrower than another. There are 4 counts for yes and 11 counts for no. In terms of the percentage, these 4 counts correspond to 27%, and 11 counts correspond to 73%. This is what we call a bar graph. The pie chart or the bar graphs are what we call the graphical displays, and in media, these are called the pictogram. And so, in summary, the distribution of a categorical variable is summarized using the graphical display, either the pie chart or the bar graph, supplemented by the numerical summaries, where the numerical summaries are the categorical counts and the percentages.